Welcome back, ladies and gentlemen. I hope you enjoyed your break. And now we are looking at a new session that's going to take place right here, right now. We're shifting to a fireside dialogue exploring one of the most important dimensions of autonomous technology, public trust. As AI becomes more deeply integrated into mobility, industry, and daily life, building systems that are safe, intuitive, transparent, are grounded in human oversight is essential to earning public confidence. Moderating this session is Dr. Majid Khanji, Assistant Professor of Computer Science at Khalifa University. And please join me in welcoming our distinguished panelist, Stefan Tampano, Chief Executive Officer, ASPIRE, Faye Ajramondi, Founder and Chief Executive Officer, MEMIC, Professor Sami Al-Haddadin, Vice President of Research and Professor of Robotics, Mohammed bin Zayed, University of Artificial Intelligence. Gentlemen, and our lovely lady, the floor is yours.
Thank you very much. I'd like first to thank the organizer for inviting me for this session, to moderate this session, and also bringing this amazing community of experts in the field of AI and autonomy. Today we have a distinguished guest of bright minds in the field of AI and autonomy. So let's dive into the discussion, to the topic about AI and human synergy. Okay? I would like first to start with a famous problem in AI, which is called the alignment problem. And the problem goes like this. Humans need to provide the right objectives and goals to the machines so that they follow them and achieve human goods. Sometimes the goals might be misaligned and give different results that are not really desirable for human. And so that's for the AI. For cyber-physical and embodied AI, usually there are some additional requirements. Real-time, safety above everything. So I want first to ask Professor Sami Haddadin about his thought about the alignment problem and alignment in AI.
Well, Majid, I think this is a very fundamental question that we are facing right now because we are, as you rightly said, moving from digital AI to physical AI. So we see cyber-physical systems acting and interacting in the real world, let it be robo-taxis, let it be the fantastic drones we see around here. We see a huge revolution in autonomous robotics coming ahead, but at the same time, we also see many potential dangerous threats, misalignments between, misalignment can mean in many dimensions, meaning in the mission, but could also be the misalignment in the safety of the systems, in the misalignment of goals. And I think one of the most important criticalities in cyber-physical systems is that safety goes first. So I feel that the AI that we want to have in the physical AI domain has safety embedded into its core. So there has been a very famous novel by Isles of kite surfers. You don't want to interrupt with the athletes, but you also want to have the right picture, right? So I feel that this physicality introduces safety as the first, I don't want to say problem, but requirement and objective. And second, I think transparency is even more important in the physical space because we want to know the causation. We call this causality. And causality says you understand cause and effect, which in physical systems is even more important. In medical applications, even more than in the, let's say, general realm. But if you think about autonomous vehicles or autonomous robots at home, these robots are not supposed to do many errors. They should understand physicality. And just 2 days ago, there was a very big leap in foundation models fused with basically physics engines, so the simulation of the physical world. And this, I think, is a very fundamental step forward compared to the standard that we see now with generative AI that is purely trained on digital data. So physical data has to be trained, but also then fused with the understanding of the physical world. And that's, I think, the biggest challenge in the alignment problem, because my understanding of the physical world needs to align with the physical understanding of the machine. And I think this is something where we not only have challenges, but also that's a good common ground. So it's not only a problem, it's also making sure that the machines understand our physical reality. And that's kind of my perspective on a high level.
Let me follow up with this. There is often the sim to real gap.
Right.
And which is a big challenge in this field. So what's your thought about that?
Oh, I have been thinking about this, I guess, for decades, to be frank, because as you know, I'm a roboticist by training, but I'm not a mechanical engineer. I'm an AI and control person, so I'm really coming from the intelligence perspective of machines. And I think humans are a very good, not let's say idle, but tool to understand what robotics intelligence means. And it all boils down to the understanding of what the sim to real gap means. Humans are fantastic in what we call do prediction. So we understand by, for example, touching a glass or pushing a glass, we are pretty good in understanding what happens due to that. And this is kind of very deeply embedded in our central nervous system, in our neuroscience, you could say. We call this predictive coding. That's what neuroscientists call it. And this idea of predictive coding, that you understand the relation between what you see, what should be happening by intervention, and then understand that not sim to real gap, but real to sim to real gap.
Got it.
And this cycle is kind of my perspective on it. Awesome. I think you can only simulate what you understand. If you don't yet understand it, if you have never measured it, it's very hard to simulate, and therefore the sim to real gap is big. I give you one example that is, I think, showing the vastness of that problem. I just come from the lab in MBZUAI, and we had two robots next to each other. One robot that has been trained on digital data only, and the other one on physical data and the digital data. And the only task they were supposed to do is I have 3 kids, I look at them a lot, to take a busy box and take an object and insert it into the other one, like a key into the hole, for example. Or if you want to assemble the drone propellers, or you want to do some mechanical assembly process. And while the system that was trained purely on digital data looked like it could be doing it, it failed all the time, while the other system that was trained with a few, and only 3-4 cycles of real physical data that it measured, so the sense of touch, you could say, was fed back into the simulator, and voila, it was able to do it instantly. And that's kind of my thought on closing the sim to real gap by closing the real to sim gap, the sim to real gap.
That's amazing. That's amazing. So let me follow up with the same question to Faye. Your thought, you're a pioneer in the edge device continuum, and how do you see this objective alignment problem in AI and autonomy?
Yeah, I think to continue based on what you started, I believe it's a context problem. And context happens on device in real world. We see ourselves constantly realigning with our objectives, just human, right? So machines need to realign with each other and with human in the loop. When you start describing the entire world by describing the context in the distant cloud, you're trying to create a scenery for what is happening here. But when we are here on the ground and we have the context lives where the data is, and based on the situation, we can constantly realign with each other and with objectives. Yesterday we had a situation as we were setting up our booth, and it required realignment. If we were not on the ground, that realignment wouldn't happen. Right? But then it got escalated to somebody else that, hey, there is an issue here, and the context is this, therefore the solution needs to be changed. So to me, it's all about physical data, physical world, and we cannot simulate the entire physical event and every condition that happens. We can create the first set of education, as if we send the kids to school, and we say, now get trained until you get grade 12. But then at some point, they enter the physical world. and they become each other's teacher. We become each other's teacher. We learn from each other based on the context, and we realign with each other at that point. So that's why everything that we do, at least from Mimic point of view, we're always talking about device first, continuum AI, and compute. Why device first? Because agents can reside on device where the data source is, and when they have the visibility to self-awareness and situational awareness. So they can learn from each other. A camera can inform a robot of a condition, so the robot can now adjust itself and realign with human in the loop.
Also.
That's why we also believe in the machine-to-machine and human in the loop, so that constantly in a changing world, they can get realigned with each other and with the world around us.
I'll come back to this part in the second question. But let me check also with Stefan, your thought about the alignment problem, and also in particular the sim to real gap. You're leading the HRL race, and you interact with lots of data, and you see the difference between these two. How do we align the vehicle safety with human goals to be safe?
It's a very important question, and I will bring a very practical example of what we have done with the Abu Dhabi Autonomous Racing League under the leadership of ATRC, which is the Advanced Technology Research Council of Abu Dhabi. So HRL started 2 years ago, and 6-7 months before the first race in April last year, we decided to build up this league with autonomous cars. Not the easiest car. We took super formulas, which are the closest car to a Formula One. We found 8 teams at a global level, people who have been already used to do some autonomous racing around the world, and we brought them to Abu Dhabi a couple of months before the race. We gave them cars with an autonomous kit on it, a computer, and a base software. Most of them have never seen in their life the Yas Marina circuit, and we start going around the circuit with an autonomous car. So pretty painful videos with cars going at 20 kilometers per hour. The first time we put a human against a machine, the machine crossed the line more than 3 minutes after the human. And so learning was complicated, and it was clear that the alignment between theoretical data, which we gave them at the start of the exercise, and practical data that they collect while they go around the circuit were very, very important. Having said that, the first competition ended up with 3 cars able to really give a show, 1 car able to go against a human, and the difference between the human and the autonomous car, driven by the TII racing team, were 9 seconds on the Yas Marina circuit, the Formula One circuit. And the driver was Daniel Kvyat, so a Formula One driver against a machine. From a technical perspective, it was amazing. From a show perspective, a little bit less, but we ticked the mark. It was what we wanted to achieve. Between the first and the second race, we have tried to understand what we could do to improve the quality and the performance of each team. And so we decided to launch a simulator. And this simulator was basically the data, the theoretical data we had about the circuit and the track, but also the data that's been collected by the teams. Interestingly, we have tested a lot of scenarios. A lot of teams have dramatically improved their ability to teach to the machine how to drive and give more style, more spirit, more personality to their virtual driver. And we end up the sim competition a few weeks ago before the race that is going to happen on Saturday with, strangely, a new team that was pretty weak the previous year, able to beat every other team because they did a great job, most likely, in matching the virtual and the real data. Now, coming to the performance of the teams in the last years, by mixing the virtual data and the real data, and by racing, for some of them, more than 500 laps on Yas Marina circuits. So for the ones that know racing, it's a lot in terms of time and effort. And mixing that with experience, now we get to 6 cars able to race together at the same time. So they all start together and they race once against the others. They overtake, they can decide to behave the way they want to behave, and most likely some of them will get out of the track and get an incident. But more importantly, looking at the pure performance, human against machine, now we are very, very close to the human time. In a couple of instances, the machine has beaten the human, but by some milliseconds, but it's there. So you can see the benefit of aligning data from the theoretical perspective to the practical perspective, and how quick it goes. It's a year time between the 3 minutes and the milliseconds.
Awesome, awesome. So, so to align data, the objectives with the machine, you need often to put a human in the loop, to have a feedback loop with humans. I want to ask you, Faye, about your thought or your architecture and how to put human in the loop with agentic AI, how to make that happen.
Absolutely. So perhaps to give the context, I want to just mention that when we say device first, what do we mean by that? I mean, if you look at right now these events, we have all these advanced machines, robots, drones, EV cars. But when you put them side by side, none of them can interact with each other. None of them can collaborate with each other. None of them can discover each other. And this morning when the show was open, there was one sentence that got stuck in my mind, that in Abu Dhabi, we're here to connect, collaborate, and advance. That's what behavior of mimicking human behavior is all about. You have to allow agents to run on each machine, independent from what the vendor is, what the operating system is, what the network and connectivities are. And now these agents can discover and collaborate with each other and advance, because it's no longer about vertical siloed application. With agentic and agentics native, we're moving from siloed apps into this concept of workflow. Workflow that works based on follow, observe, respond, and learn, just as we do. We follow your prompt as a question. We observe the condition in environment and what my colleagues are saying. We respond accordingly by passing the information to each other and enrich the knowledge, and then we learn from this and feedback to the system. And we don't need an intermediary up there that for every question that you ask, I pick up the phone and ask, hey, can I now say this? Can I now say that? So that's what we mean by device first, continuum, AI, and compute. Why device first? Because that's where data is. I first call my own API, and then based on my capability, I decide whether I need someone else here or I need to escalate out there. And that's how we bring human in the loop. Because by having agents running on each device and by being able to measure the performance, the credibility, the behavior of each agent and how they interact with each other, we can enable them to also adhere to the policy, sovereignty in execution, and flag, and their response is that, hey, I don't understand this human. What did you mean by this objective? Nice, right? Yes. And that's how everything can work across different systems seamlessly as mimicking human behavior.
Awesome, awesome. So let me follow up with Dr. Sami about this, the human-machine interface and the feedback loop. How often should the AI prompt the human? Like, you might tell me maybe the architecture or the high-level view of your technical stack, because if the AI is prompting quite often, then it becomes tedious and you will not react. It's the technical term, they call it crying wolf syndrome. Mm-hmm. Every time the AI is saying there's a wolf, there's a danger, you will not react to that. So what's your thought about the frequency of prompting the user?
That's another, I think, fundamental question in this whole alignment context, but in the physicality of AI. So what I think was really great as an output of what has been said is that AI moves away from being, let's say, an information retrieval system towards becoming an interaction partner. And I think this is really what this is all about. So interaction is more like a conversation, whether it's a verbal conversation, whether it's a physical conversation, shaking hands, multimodality, but it's very different from this idea of a service, AI as a service basically, right? Which is a question and answer. It's a bit like I have the question, you give me the answer, I have the next question, you give me the answer. But if we have a conversation, it's not about questions and answers, it's about the conversation per se. And I'm just saying that because I think this is a bit the answer to your fundamental question about what is the right level to do conversation. It depends on two interaction partners, the humans, maybe one, many humans, and the robots, the many robots or one robot. So depending on what's the objective of what you want to achieve and depending on the competency and the individual profile of the human, the interaction might look very different. Let's say you're basically only operate, and only is just meaning in the sense of agency. So the human is the remote driver of an autonomous car. We call this shared autonomy, which means it just gives the rough steering input, but all the other very complex actions in the car are being done by the machine. That is a clear leader-follower problem. So there is not a lot of feedback except for the car itself. But the more agency the robot car, the robot becomes, or the more competent it becomes, it depends on my competency again. So if I'm a world-class surgeon using a robot to do a very complex surgery, I maybe want less activity of the AI robot. But maybe if I'm a surgeon in training, I want to have more activity of the robot. It helps me because it learned from other world-class surgeons. So I think the answer is really depending on the problem at hand. And for this, the AI needs to have one core competency, which is very different from all the AIs that we are carrying around in our pockets. It's anticipation. The AI, like you and me, have anticipation of each other. We have certain models. We can respond proactively to this conversation, to the situation. We can align to the individual. And I think this is really the core competency. So the answer is basically AI needs to have that competency to give the right level of interaction subject to the task and subject to the individual it is interacting or obeying to. So that's, I think, fundamentally what it is all about.
Awesome.
And how do you measure it? By the quality of the service that you can achieve. Surgery can be measured, the outcome. Autonomous driving can be measured, have zero accidents. If you want to think about autonomous flight, energy efficiency could be another measure. So there's many, many KPIs that you could track to really objectify the performance of this agency and proactivity and interaction capability of the AI.
Awesome, awesome. That's so. Let's. I want to ask you, Stefan, about another slightly adjacent topic to this alignment problem and also communicating objective, and which is basically the open source aspects, the source code of the AI, or the open data sets that you're quite involved in the A2RL.
Yeah.
So what's your thing? What's your thought on open source and how important do you think in this AI development?
Well, critical. Critical because if we don't have enough data to feed the AI, we're going to be stuck, and the performance we are going to generate will not be enough. That's why in A2RL, a lot of the teams that participate to the car or the drone competition have actually shared most of the data they have collected and most of the models they have put in place. And I think that's, from a collaboration perspective, fundamentally, it's part of A2RL and a TRC journey to put together the best talents and actually access information as much as possible. And there will be areas where it will be sensible to and difficult to get access to the data. Awesome. But I think to foster progress, it's important that the data get shared.
Awesome. So, Faye, I want to also ask you the same question, but slightly in a different context. So, in the past, not so far past, open source used to be common sense. For companies, it's always good to rely on open source because you hire talents that are already trained on open source, right? So you don't need to retrain them. But in the last few years, there's a new idea in the AI community that sharing weights is risky, right?
Shared?
Weights, neural network weights, sharing models, sharing the data about the AI is risky because some bad actors might take it, right? So I just want to hear your perspective about that. Is open source still valuable or is dangerous? What do you think?
I think it's more about open API than open source. I personally believe that our next economy is going to be thriving on our data, whether it's my data, enterprise data, or nation data. And I believe that needs to be treated as the most precious currency of our lives, because I don't believe by the time AI takes over, I don't have anything to contribute to, right? So, and that's the only economy I have is my interaction with this system, with this world, that enriches the data to elevate its AI, to elevate its knowledge, right? So, and when we talk about AI, I wanna highlight that I don't see AI as one single entity. I see AI as this mesh behind us is moving. Billions of agents are going to be running. Agents are like single capability task. I'm a walking 1,000 agents. You're a 10,000 agents. This is a 10,000 agents.
Yeah.
And these agents are going to be part of our everyday life. And knowledge as a service economy, because SaaS is dying. SaaS is dead, practically. It's about knowledge as a service economy. So if we take all that back and if we look at a knowledge as a service in the world where an enterprise is running their agents almost like the employee, the single task employee, and the enterprise is relying on those single task employee, and it can measure the performance of each one of them at every point, and look at it from every perspective, the camera, from the robot to the billions, hundreds of agents that are running in the car. It creates almost a feedback loop and a dashboard for me to see how the system was operating. Did they perform? Didn't they perform? Is any of the agents went rogue? How can I apply, enforce bringing that single agent down? And who is accountable for it? I think in mobile internet, we lost accountability. You know, I often say applications doesn't work. Who you going to call? Ghostbuster? Or another form that presented in front of you to fill in and submit it and don't know how the system is going to respond to you. So who is the better business bureau of future? Because and how do we hold the producer of agent, the producer of AI model accountable to say, hey, your system actually didn't provide the behavior that was supposed to provide. It consumed too much energy. It creates too much cost. It has too much latency across them. So if we look at it from that context and agree that the knowledge and data belongs to the producer of the system, the data, then you come back to accountability and you look at it is that, do I need open source or do I need open API so that system can interact seamlessly and I have visibility to accountability as a whole?
Awesome, awesome. So, okay, so I want to move to an adjacent to Professor Sami. So, about the topic of talent loop and human talents, those who are going to develop the open source, right? You are in Mohammed bin Zayed University of AI. And I want just to put one idea, might be a little bit provocative, in a sense that there is a study which says that humans produce around 20,000 tokens a day. And human thinking tokens is around 200,000 a day, right? And if you look into the cost of intelligence, the latest Grok model is around $0.5 for input and $1.50. So it's getting very cheap. So the cost of intelligence is reducing dramatically. So my question to you as a professor and a researcher in Mohammed bin Zayed, do we need humans anymore?
You're also asking whether I should cut my salary by half, I guess, in a way. So I think there is a bit more to it than just Let me connect that to the open source question, just to answer it from a different perspective. I think this is actually quite interesting. So we heard a lot of discussion about products, which I think a lot of these discussions make sense. You want to have accountability, certifiability, and all that stuff. But if you think about knowledge, intelligence is about creating knowledge. So that's kind of the bridge to your question. if you want to create knowledge, and that's kind of my profession, right? We want to create knowledge on the one side, and at this other side, we want to give knowledge to our students, to our talents, so that they can create new knowledge. And this is a very different kind of intelligence compared to the intelligence that you're referring to that can be created by AI at the moment. Because typically what the AI can do at the moment is being more like a very smart encyclopedia, you could say. So it is you could say the knowledge of the world, at least the one that we see in the internet. Half of it is knowledge, the other one is maybe half knowledge. Many facts, others are not so certain, but it is kind of the access to that pool of information. I'm not sure I would call that intelligence. That's like a smart librarian in the end, right? So it's very good to assist me in doing something such as knowledge generation. So yes, you are right that the cost of information retrieval of the librarians of the world has reduced dramatically, and it will continue to do so. Awesome. At the same time, there is a counter kind of wave. People who produce knowledge can create more knowledge faster than before, because they are able to reduce the time that they have to spend on all the services that were there before. The Nobel Prize last year was given to predicting protein folding, the chemistry Nobel Prize. And Demis Hassabis was just at MBZUAI last week and visited us. And the discussion was really about what's the next step in science, AI for science, AI for natural sciences, for physics, chemistry, you name it, medicine. So I think the answer to that is essentially the cost of information, retrieval, and access can be dramatically reduced. However, and that's why I'm coming now to the open source, however, only if our knowledge and information are made available. Awesome. So now I'm coming to the closed source and open source. If our knowledge how to create that technology is closed, I cannot teach my students how to do it. I cannot tell them, how can you create the tools of tomorrow? We claim that it's the age of AI. Okay. If I want to train the next generation, the current generation, and the generation before me to be able to use and maybe even be part of the full value chain, I need to be able to train them to develop that technology. I think this is the biggest argument against closed source in the knowledge part of the value chain.
So we still need the students, not data centers only.
Exactly. As an innovator, I would say, absolutely, that's a product. Yes. There's all these aspects. However, as an educator, I would say knowledge free for everybody, and that's why we as MBZUAI, we actually believe very heavily into open source, and we actually developed K2Think, as probably most of you know, as a truly open source initiative with the open code, open data, and so on and so forth. And we continue to drive that because we also internally use it in our everyday education of the students. Awesome. So our bachelor students are able to train, develop, train, and deploy foundation models, which is a key skill.
Awesome. Last thought, Stefan, about, please go, please.
No, I was going to say, I don't know if the mic is on. A couple of points. I'm not sure if the cost of tokens are going down realistically, but artificially. The fact that Cursor, I mean, it was on news that Cursor charges developer $500, pay OpenAI $1,000, OpenAI pays the cloud provider $10,000, and then a cloud provider pays hundreds of thousands of dollars for the chip. So it's a question of whether the cost of token is going down realistically or artificially. And we're not even measuring the cost of energy, the cost of bandwidth, the cost of network. I encourage everybody to read a white paper we published on arxiv.org. But also, when we look at the quality of knowledge, I often tell people that just think about why Sam Altman from OpenAI paid $6.5 billion for the design lab of Johnny Ive, a design lab that creates a sketch of the hardware. That's because that's where the quality of data and context is. Because when you feed LLMs on available information on internet, you're not actually achieving quality of data. You keep increasing the garbage up.
Yes.
And talents are important to be trained on fundamentals so that they can ask the right question and participate in the next economy.
Stefan, your final thoughts.
Final
5
thoughts.
seconds.
Practical application to what the scientists are referring to. In our A2RL teams, the teams that have made the biggest quality jump are teams that have played Mercato, like you play Mercato in soccer. And they've been buying expertise from another team, transferring experts, and these guys actually are able to interact with the theoretical AI, if you wish, and make it better. I believe the quality of the people we put in front of AI is fundamental for the time being and for the coming 2-3 years, maybe more, to keep on pushing. And since the human will remain in the loop for a while.
Thank you very much for this amazing conversation. I think we need 1 more hours to cover these topics, so thank you very much.
Thank you.
Thank
Please.
you.